Good morning, everyone. Today we are continuing with Unit 2 Data Engineering. Now that we know the data, how the data is formatted and distributed in file system, we will learn how to optimize the storage for faster searching using partitioning and packaging. Explore the cloud object storage option like AWS, S3 and GCP and cloud storage, and look at how the data modeling works across different storage architectures. Think of it as organizing a massive international library. We will discuss how to divide books by language, split them by alphabetical order, look at the physical cloud warehouse where we rent self space, and understand how the blueprint of the library is designed. So next one is partitioning. So partitioning means dividing the massive data set into a physically smaller distinct folder based on the unique values of a specific column such as date, year, region. When you run your query filtering by the column, the system can instantly jump straight to that specific folder, completely skipping the rest of the data set. This dramatically increases performance. For example, look at the example on the slide. Instead of putting all sales data from the past decade into one gain, the messy files to create the master folder called sales. Instead, we make individual folders of year 2024, 2025, 2026. If a business analytic needs a report on 2026 sales, the computer completely ignores the 2024 and 25 folders, cutting down search time instantly. Then bucketing. While partitioning creates the folders based on explicit categories, distributes the data into fixed predefined number of fields based on the mathematical formula called the hash function applied to the specific column. It is then fantastic for columns that have millions of unique values where the partitioning would not work well. Imagine you have a million unique customers. If you try to partition them by customer ID, you won't accidentally create a million tiny folders. So, which ruin performance. Instead, you use packaging and tell them system distribute these customers evenly across exactly 4 files. Packet 1 to packet 4. The system calculates the hash values for each ID and instantly assign them to specific file, ensuring all data perfectly grouped and balanced. So AWS. So S3 is a simple storage service. So moving to the cloud infrastructure, the AWS S3 is an Amazon highly popular cloud-based object storage service. Instead of managing the physical hard drives on the premise company, the companies rent space from Amazon to store data as object inside virtual container called packets. It is highly scalable, incredibly durable, and serves as absolute foundation for building a cloud-based data lakes. So think of AWS S3 is like a digital infinitely expanding self-storage unit facility. You don't care how the facility physically organized, the boxes behind the screen. You just pay a cheap monthly fee to drop your file there safely, and you can pull out one file or 10 million files wherever you need them. So GCP cloud storage, just like Amazon has S3, Google Cloud Platform offers GCP cloud storage. It is also a highly scalable, secure, and cost-effective object storage service. It is deeply integrated with Google's powerful data analytic tools and is heavily used for storing large machine learning datasets and backing up corporate data. So data modeling for data lakes and warehouse. So finally, let's talk about data modeling, which is the blueprint or architectural design to how the data structure for optimal storage and analytics. So this design changes dramatically depending on where the data lives. So data lake modeling uses the concept called schema on road. So schema on read. You store raw and filtered data so into the chief folders with minimal rules. The structure is only applied when an analyst reads the data. Uses the concept called schema on write. Before any data is allowed into the warehouse, it must highly proceed, clean, and forced to fit the strict, rigid relational table blueprint. So, thank you.